To solve an absolute value inequality problem type 3, notice the difference is instead of having plain W on the inside, I have a little bit more going on the inside of the absolute value, but the process is going to be the same. Step 1, copy down the problem without the absolute value. So W plus 3 greater than 4. Take this symbol, slide it over. And then that 4, we're going to make it negative 4. Once you get it set up, you need to decide, is this an and problem or an or problem? So we're going to look at these symbols, greater. Whenever you have a greater than symbol or greater than or equal to, it's an or problem. So I'm going to have an or. Chances are, if it's an or problem, the graph is going to end up looking like paddles, like oars. Then I'm going to cover up this one and write negative 4 greater than W plus 3. And then I'm going to cover up this one and write W plus 3 is greater than 4. I have 2 inequalities to solve. To get W by itself, I'm going to subtract 3 from both sides. And so negative 4 minus 3 is negative 7. I have a greater than W. On this one, I'm going to subtract 3 from both sides. So W is greater than 1.
Because when it's facing this one,
Okay, then after that, I'm going to put at negative 7 and at positive 1, I put open dots because they're not underlined. We're not including those numbers. So negative 7 open dot, 1 open dot. And next I want to decide, are the numbers in my solution to the left of negative 7, in between negative 7 and 1, or bigger than 1? The true understanding of it is when you have an or, the number is a solution if it makes at least one of those true. You can also test any number to the left of negative 7 in the original. So if I were to put negative 10, which is a number to the left of negative 7, back in the original, negative 10 plus 3 is negative 7. The absolute value of negative 7 is 7, and 7 is bigger than 4. It's true. So what that tells me is every number to the left of negative 7 is a part of our solution. So to show that, I'm going to put an arrow going that way. I can pick any number I want in the middle of negative 7 and 1. Perhaps I select 0. And if I put 0 back into the original, 0 plus 3, absolute value is 3. 3 is not bigger than 4. It's not true, so in between, none of these numbers work. And then lastly, pick a number to the right of 1. If I went with 2 back in the original, it makes it true. So I'm going to go to the right. Okay, so I can test this number in the original, or I can test the number in each of these separately, but when it's an or, it only has to work in at least one. Where a shortcut is, because it's an or, notice the arrows went away from each other. Okay, so let's just follow that same process here. I'm going to write down the original without the absolute values. I'm gonna slide that symbol over. And then that 7, I'm gonna put a -7 and it's started. Then I'm gonna decide it is it an and or an or problem. Less thans, and, so I know I have an and. And then I'm gonna cover up this side, -7 is less than or equal to W plus 2. And on the right, I'm gonna cover this part up. And I have W plus 2 is less than or equal to 7. We're gonna go ahead and use the shortcut all the way here, so I just need to solve each one of these. If I solve this one, I'm gonna subtract 2 from both sides. And I get -9. Here I'll subtract 2 from both sides. And I have 5. So if I use the shortcut, I'm gonna go to my number line right now, and at -9 and at 5, I'm gonna put solid dots. Because this is an and, I know that it's gonna connect up in the middle. And there's my final graph. If I really wanted to, I could pick a number to the left of -9, a number in between -9 and 5, and to the right of 5, plug them into the original. 0 is the only one that would make the original true, or I could put these numbers into these, and for and, it would have to make both of them true. Okay, here we go. Yeah. Subtraction like here,
Yeah.
then to get this by itself, we would add 2.
So it would be
No, and if I had multiplication, you would divide. If you had division, you would multiply. But yeah, it would be the same. So just step 1, copy it without the absolute value, slide that over, change that sign on that number, decide if it's an and or an or, write your 2 separate ones, solve them just by adding or subtracting, get the letter by itself. Then put dots on there, solid if it's underlined, open if it's not. And if it was an and, they're probably gonna connect, and if it was an or, they're gonna go away. And then all the extra math, you know, that's in there just to verify is that a solution means that the number works in the original or the number works in both when it comes to an and. And in this one, if it's an or problem, these numbers are gonna work in the original. And then if it was an or, it has to work in one or the other, so in at least one of those. Okay. All right, good question. All right, so then the last one, 114.